Hello everyone, I hope you all are doing great. Today is a very interesting lecture and I'm very much excited about it. We're going to learn and code a very first machine learning algorithm, which is the linear regression. So the lecture plan is as follows. I'm going to start off today's session by discussing the basics of linear regression, followed by the base code. This base code contains all the skeleton code and the syntax and all the steps which we discussed in the previous lecture, followed by visualization, how to visualize your laws using matplotlib and how to use TensorBoard, a very useful tool for visualization. Finally, how to store and restore our model. Linear regression. The term regression refers to predicting the output, numerical output of a given model. So, as the term suggests, linear regression is basically finding out output of a linear model. So, for example, let's look into the case of housing rates. So here these stars denote the housing prices for a given area. So x-axis is the area of the housing plot and y-axis is the corresponding price. So this star is my input data. So what I have to do here is build a model that can predict the prices given the area of the housing. So here this blue line is the line of best fit. Now we need to construct a model in order to predict the prices given the input. So let's first do the math followed by the code. So we need to model in such a way that a function takes an input as area and outputs the price. To generalize this, we need a simple function which takes in the value of x and outputs the value y. So it's a linear model. So basically a linear model can be equated to a straight line. So given x, we have to calculate y, and our model parameters are nothing but the slope and the intercept. So with the training data, I would calculate m and c, and for testing I would use these values and find how my code is algorithm is performing with real life data. Okay, so now talking in terms of machine learning, the same code equation can be written in terms of weights and bases, bias, sorry. So W is the weight and B is the bias, and these two combine the model parameters. So as discussed earlier, the very first stage is to pre-process my data. So once I process my data, the second step is to create your model. So here my model is this. Capital Y is weight times the input vector and the bias. And third step is to train the model, find the model parameters, and finally test it out. Now let's code it in TensorFlow, and I'm going to go step by step, and these steps you should follow on almost every other machine learning, deep learning algorithms. So the steps are quite same, and the syntax is also same, So try to listen to this particular segment very carefully, and if you are not able to follow, please write in the comment section. So I'll try to make it clear. Okay. So let's get started. First step is to import all the necessary packages. So I'm going to import NumPy to generate my input data, and of course I'm going to import my TensorFlow package. The second step is to input your data. Here I'm going to generate it instead of inputting it. So my x is going to spread from 0 to 10 and 100 points between them, and y is a straight line, basically a straight line. So I'm going to generate a straight line. So y is 4x plus 6. So m is 4 and the intercept is 6. You can add some noise. So instead of giving 6, I can go on and give random, but to make things simple, I'm going to give 6. So my model has to predict 4 and 6 as the weight and the bias respectively. So let's see how it performs. The next step is to define model parameters. Our model parameters are weight and bias respectively. So, and both of them are variables. So go ahead and assign W weight and B bias to TF variable. Okay. It's always a good idea to name your parameters, placeholders, etc. Because when you are navigating through a graph, it's really handy when you name them. So you'll see them later. Okay. Moving on, define your placeholders. So here my x and y are the placeholders. So I'm going to name it also, so to make things clear. Okay. The next step is to define my model. The model predicts that y is wx plus b. Okay, so I'm going to use built-in math functions in TensorFlow to carry out this operation. So first multiply x with w. So use tf.mul, stands for multiplication, and add the result of this multiplication operation with the bias. Okay. Moving on, this is my model. Firstly, I'll calculate loss. So here I'm using method of least mean squares. Okay. So I'll discuss more about loss and optimizers in a different lecture. So please bear with me here. Okay. So there's lots to discuss about losses and optimizer. So don't worry. Just remember I'm using gradient descent optimizer here, and to calculate loss I'm finding out the difference between the predicted output and the actual output, and I'm taking the mean of the square. Okay, so and the optimizer I'm using gradient descent optimizer with a parameter value of 0.01. So don't focus more on this part segment of here, so I'll discuss more later. Okay. Moving on, I need to start my session, TensorFlow session, and I need to initialize all the variables. So my variables are weight and bias. So initialize them. So tf.initialize all variables is the function to initialize variables, and using my session I would initialize all the variables. Okay. So and figure out how much iterations you want to carry out. Okay, so I'm going to carry out around 200 iterations. Since I would be running it as an iteration, I need a for loop. So write a for loop, and for each and every step in this particular epoch, I'm going to run my algorithm, train it, calculate the loss. Okay. Simultaneously feed the placeholders with the input data that you have generated, x input and y input. X and y are the placeholders. Okay, so your y will be used over here, and x will be used to calculate the predicted value of y. All right. So, and I'm going to print the value of the loss every once in every 50 steps. So here this would return me the loss that my code calculates. Okay, and finally I'm going to print the model parameters, and so I'm going to print the weight, and sys.run w returns me the value of the weight and the bias. Okay, and to conclude, I need to close my session also. Okay, now let's go ahead and run the code. So here you can see the model parameters. Hooray! So the weight, the predicted weight is 4.0. It's approximately 4, and the bias is 5.9 something, which is very close to 6. So as our model, it is 4x plus c. The weight should be 4. Yeah, it's fairly accurate, and the intercept should be 6, which is the bias. So was that really exciting for you, predicting the outputs? So our model is fairly accurate. The thing with linear regression, if you the parameters are correct and your code is correct, it will always converge to a minimum, global minimum. It's called a convex problem. So you have a global minimum here, so it will always converge to it. So moving on, it's always also good to visualize your loss. So let's see how to do with matplotlib first. Okay. In order to plot your function, first import your plotting package, matplotlib. Inside matplotlib, there's a function for plotting, pyplot. Okay, so import pyplot. Okay. So it's just the same code, but I've added few lines for plotting. Okay. So here I am plotting the loss with respect to each step. Okay, I'm going to plot loss for every 50 steps. Okay, so and I'm also storing the loss. Okay, so it's just the same code, just add few lines for plotting. Okay, so inside your for loop, for every 50 steps you plot the loss. So here L1 of step returns the loss at that particular step, and I'll be plotting that corresponding loss. Okay, so here I'm storing the loss. Okay, I'm declaring it, then I'm storing the loss. Okay, these four lines are for plotting. Okay, so I'm defining an axis till the end of the iteration. Okay, and I'm passing it for 0.01 duration, and for showing the plot. Now let's see how the plot goes. Here you can see some nice plot going on. So it goes till 2000, which is my iteration. So this is the visualization of my loss using matplotlib. Now let's see how to visualize using TensorBoard. TensorBoard comes with TensorFlow. It's a very powerful framework for visualization. Okay, there are lots of things we can do with TensorBoard. You can visualize your losses. You can visualize your model. Once we build a very complicated model, this comes in very handy. Okay. Now, before we dive deep into TensorBoard, I would like to discuss some of the important functions. tf.scalar summary stores the values in the TensorFlow. So these are the values, and we give it a tag to access them. For example, I want to store my loss. Okay, so the values would be the loss, and I give it a tag loss. So this is all about this particular function. Moving on with the name scope. Name scope comes very handy in grouping items together in your model, especially when you are visualizing the model. So all the things that you would like to see it as a group can be written, can be achieved using name scope. Once we look into the direct example, this would make sense to you. And tf.merge all summaries merges all the scalar summaries and other summaries into the TensorBoard file. And this is the summary writer function, and it writes the summaries into this particular path. So we mentioned the path over here, and the corresponding session graph. So can also assign it to the default one. And inside summary writer, there's a function called add summary, which adds that summary, and also you can mention the epoch number. So here it's the step is nothing but your particular iteration. Okay. Now let's use these functions into our code, and let's see how to use TensorBoard. The same skeleton code, I'm gonna add few more lines for my storing my model and using it in TensorBoard. Okay. The first thing is I'm gonna give a lot of name scope. So I'm gonna club this x and y into this particular name called input, and name it input because x and y are my input. And the model is the predicted one which we try to achieve. So this is my model. I'm going to give group it under the name scope model, and I'm calculating loss, and in order to visualize loss in my TensorBoard, I'm going to give it a loss. Okay. And in every single epoch I'm going to store my loss and see it in my TensorBoard. So I'm going to add a scalar summary here for loss, and followed by this merge summary function and the summary writer. And here I'm giving the path to my folder, and this is just a path to the folder, and this is the graph session. So I'm saving the default graph session, and inside my for loop, so every single epoch I want to save my loss. Okay, so the summary writer adds the summary which is written by the merge summary operation, and which stores the loss for every single step. Okay, so this is all about the codes for TensorBoard. Let's see live in action. Once you run the code, navigate to the terminal. Near terminal, just write TensorBoard and write the path to where the TensorBoard files are located. This is exactly the same path which you have mentioned in your code also, and run it. So we can go to this particular site in our web browser and access TensorBoard. I've navigated to that particular address. So there are lots of options here: the events, images, and the graph. Okay. Now since I have put a code for storing the loss, and I have given it a tag loss also. So hooray! So here you have a nice plot of your loss. This has each and every step epoch, so you can easily navigate through them. You can see the corresponding loss and the corresponding step in your left hand side. Alright, so this is all about visualization of the loss, and you can add other parameters as well. There are lots of other features. in near future we'll explore more. Okay, so now in the graph, so this is my model. Okay, so now if you remember, in my code I have clubbed both x and y. I've given it a name, input x, input y. So I've clubbed it in input. This is the name scope with the title input. This is my model. In model I have given these parameters. So you can see it's a very nice visualization, and naming it is very helpful for me. So in the model I have given both weight and bias. So basically I multiply my input x with the weight and then add it with the bias, then I calculate the loss. So this visualization is very helpful for me. Okay. So that's all about visualization using TensorBoard and Matplotlib. So you see it's a very helpful tool. Okay, now moving to the final part of this session, let's save and restore our model. Okay, in order to save and restore my model, TensorFlow has a function called saver. It's inside the train tf.train.saver. So I'm gonna assign it to saver here for simplicity. Okay, so once my code has been executed, I'll save my model. So saver.save is the function inside saver to save my model. This is my session name, and this is the path where I want to save my model. And note here the syntax. So the file will be saved it as ckpt.ckpt checkpoint, and I can give it a name. Alright, so once you run this model, it will save it, and you need for restoring, you can restore it in the same code, or you can write a new script. So I have written a new script here. So uh, if you when you are writing another script, so be sure to write which all variables you are trying to retrieve. So if you're trying to retrieve weight and bias, so again assign to these two w and b. Okay, and uh, call the trainer.saver function. Inside this saver function, there's another method called restore, and restore my session, and give the path to the model where you have saved exactly the same. Okay, and note here I haven't initialized my variables. So because I'm restoring my variables, and they have been already initialized, so there's no need to initialize the variables again. I'm gonna run my script from terminal this time for a change. Okay, so I've already navigated to the folder. Okay, so I'm gonna run it. So these are my model parameters. Weight is 4.00 and the bias is 5.982. Okay, now my code for restoring the models is restore.py. I have saved it in this file. Okay, okay, you can see it's exactly the same variables. Okay, so in this file I just saved and restored my model parameters. With this we come to the end of this session. So to have a quick recap, we first learned how to input our data or generate our own data, as I did in our case, and followed by how to define model parameters, how to write your model, how to call and send the inputs dynamically to the algorithm, and followed by how to plot and analyze the data, and how to use TensorBoard, finally, and how to save and restore your model. For many of you, I think this would be your first encounter with TensorFlow, and I can guarantee you this would be the skeleton and the basic structure of code, and which you would be using it in all the machine learning algorithms. So, in case you had some discomfort, don't you worry. So, in the upcoming lectures, also, I'll be discussing some basic algorithms before we start deep learning and code it in TensorFlow. So, I think it would make you feel comfortable with it. Okay. Hope you guys enjoyed this lecture and have a nice day. Signing off. Thank you.